Hello, my amazing students. This is Mrs. A, and I love math. And today we're on lesson 76 of our Saxon Orange book, and we are talking about one of my favorite subjects because it's fun. We're going to talk about consecutive integers and how to model them and how to do consecutive integer problems. I think you're really going to like this. So, when we're talking about consecutive integers, we're talking about integers that come one right after the next, like 1, 2, 3, or 6, 7, 8, or 24, 25, 26. Okay, so consecutive integers follow each other one after the other. Okay, so if we call the first consecutive integer 1, then the next one after it would be n, then the next one would be n plus 1, and the next one would be n plus 2. Let's check it out and see how this works. If I start with n is 0, then n plus 1 would be 0 plus 1, or 1. If I start without n is 0, then n plus 2 would be 2, and don't I have 0, 1, 2, 3, consecutive numbers right in a row? Okay, so what if I do this one? I start with n is negative 3 right here. Well, the next one would be negative 2, and the next one would be negative 1. All right, let's see what happens. If n is negative 3, negative 3 plus 1 is negative 2, and negative 3 plus 2 is negative 1. And don't I get the sequence that I want? Okay, so then we start with 3. And here's 3. So 3, 4, 5 is what we're looking for. So if n is 3, 3 plus 1 is 4, 3 plus 2 is 5, 3, 4, 5. If n is 26, way off our chart, then we want 26, 27, 28. 26 is n, so 26 plus 1 is 27, and 26 plus 2 is 28. Okay, well, since we see that that works, then if we wanted 4 consecutive integers, wouldn't we call the next one n plus 3? And then the next one after that, n plus 4. And we could go on and do this all day long. Okay, so here's our first example problem. Find 3 consecutive integers such that the sum of the first and the third is 146. So we're looking for 3 consecutive integers. So we would call them n plus 1, and n plus 2. Now the ones that enter into this discussion are the first one and the third one, but we're wanting to find all 3. So this is our assignment. So now it says the sum of the first and the third is 146. So the first one is n. The third one is n plus 2. So n plus 2 must equal 146. Well, that's simple because we only have one variable. So we're going to subtract the 2 from both sides. And then we have n plus n is 2n equals 146 minus 2, or 144. So to find n, don't we just need to divide both sides of the equation by 2? So n is equal to, let's see, divide 14 by 2, and I get a 72. Okay, so n is 72. So let's check it out. If n is 72, then n plus 1 is 73. Then n plus 2 is 74. And if I add 72 and 74 together, I get 146. And I solved the problem. So my numbers are 72, 73, 74. And this was the equation that I used to figure it out. Okay, so here we have the next example. Find 3 consecutive integers. Now remember, let's recall that integers are positive and negative whole numbers. Okay, 3 consecutive integers such that twice the sum of the first 2 is 2 less than 3 times the third. Oh my goodness, that's kind of complicated. So twice the sum of the first two. Well, the sum of the first two would be n plus 1. And we're going to take twice that sum. So twice that sum. Twice the sum of the first two is 2 less than 3 times the third. Now the third one, remember, n plus 1, n plus 2. All right, now let's first, before we start to work this out, let's see if my equation says what this says. Okay, so 3 consecutive integers, n plus 1, n plus 2, okay, such that twice the sum of the first two, n plus 1, added together, that's the sum, twice that is, that's my equal sign, 2 less than, means I'm going to subtract 2 from the n, 3 times the third. Yep, I think it's going to work. So now let's simplify all of this. So n plus 1 is 2n plus 1 times 2 equals 3 times this is going to be 3n plus 6 minus 2. Okay, so now I have twice all of this. So 2 times 2 is 4n plus 2 equals 3n plus 4. Okay, now I have a 4n and a 3n. So could I just subtract 3n from this side and subtract 3n from this side? Okay, so now I have n plus 2, n plus 2 equals 4. So now I want to get rid of the 2. So minus 2, minus 2. So n is 2. Okay, n is 2. So I'm going to write it there because I ran out of room. Now, let's check. If n is 2, then n plus 1 is 3. And n plus 2 is 4. Okay, so let's check. Twice the sum of the first two. That's 5 times 2 would be 10. Okay, is 2 less than, so minus 2. 3 times the third one. The third one was 4. So 4 times 3 would be 12. 12 take away 2 is 10. And it is confirmed that the 3 consecutive integers are 2, 3, and 4. Isn't that fun? Now that's Mrs. A's idea of fun. This is our last practice or example, and then we're going to do a couple practice problems, and then you're going to be on your own. Find 4 consecutive integers such that 6 times the sum of the first and the fourth is 26 less than 10 times the third. Okay, so first of all, so we don't get confused, 4 consecutive integers. Let's go ahead and decide how to model those. So n plus 1, n plus 2, n plus 3. Those would be the 4 consecutive numbers, and that's how we model them. Now, such that 6 times the sum, so 6 times the sum of, the sum is a plus, right? The first and the fourth. So the first is n, and the fourth is n plus 3, is 26 less than, so we're going to put our equal 26 less than 10 times the third. So 10 times the third number would be n plus 2. Okay, let's first check and make sure that our model is correct. Okay, so find 4 consecutive integers such that 6 times the sum of the first and the fourth is, that's my equal sign, 26 less than, means a minus 26 at the end, 10 times the third. 10 times 1, 2, 3. The third in my model is correct. So now let's start to simplify. N plus 3 is 2n plus 3 times 6 equals 10 times n plus 2 is 10n plus 20 minus 26. Okay, so then I multiply this out. I get 12n plus 18 equals 10n minus 6. So with a 12n and a 10n, if I subtract the 10n here and subtract the 10n there, I'm out of space, I end up with 2n on this side. So 2n, we'll make our little equation here. 2n plus 18 equals, now this is gone, minus 6. Okay, so I got this little thing here. 2n plus 18 equals negative 6. I need to get the 2n by itself, so I'm going to subtract the 18 and subtract the 18. So now I end up with 2n. This cancels. A negative 6 and a negative 18, hopefully you can see that, is a negative 24. So if 2n is a negative 24, then wouldn't n divided by 2 equal negative 12? So if n is negative 12, and then I add 1, I go to negative 11. And then I add another, so negative 12 plus 2 is a negative 10. Negative 12 plus 3 is a negative 9. So let's check and see if we have the right 4 consecutive numbers. 6 times the sum of the first and the fourth. The first and the fourth added together is negative 21. So 6 times negative 21 is 26 less than 10 times the third. So 10 times the third would be negative 100. Because that third one's negative 10. And 10 times that would be negative 100 minus 26 would be negative 126 on this side. Okay? And then if I multiply 6 times a negative 21, don't I get a negative 126? And it works. So our numbers are negative 12, negative 11, negative 10, negative 9, and that's our last example. So I'm going to hold it here so you can see all of that mishmash. Hopefully you were following me as we went along. And let's do some practice problems. All right, so here we are on our first practice problem. It's a pretty easy one. The second one's a little bit spicier, but it says find 3 consecutive integers. So we're looking for an n plus 1, and an n plus 2, such that the sum of the first and the third, so the sum of the first and the third is 142. Okay, so now we work this out. N plus 2 is 2n plus 2 equals 142. Subtract the 2 to get rid of it. 2n is 140. So n divided by 2 on both sides is 70. So this would be 70, 71, 72. So let's check it. All right, so the sum of the first and the third, 70 plus 72 is 142. That one was pretty simple. Oh my, this one's pretty long. Find 4 consecutive integers. So now I'm looking for n plus 1, n plus 2, n plus 3. 4 consecutive integers such that 8 times the sum of the first and the third is 40 greater than 10 times the fourth. Okay, so 8 times the sum, so 8 times the sum of the first and the third. So the first is n, and the third, 1, 2, 3, is n plus 2. You can put that in parentheses if you want. You don't have to. And the third is 40 greater than. So plus 40 on the n. 10 times the fourth. And the fourth is n plus 3. So let's read it again and make sure that our representation is correct. Find 4 consecutive integers such that 8 times the sum of the first and the third, and that one is our third, is 40 greater than 10 times the fourth. All right, so it looks like our representation, our model is correct. So n plus 2 is 2n plus 2 times 8 equals 10 times n plus 3 is 10n plus 30 plus the 40 over here. So I get 16n plus 16 equals 10n plus the 70. Okay, so this is my equation. So 16n, and then if I take the 10n away here and the 10n away here, then right here I get 6n. 6n plus 16 is, this goes away, is 70. Okay, so now I want to get rid of the 16. So I subtract the 16 and I subtract the 16 here. And I get 6n equals 70 take away 16 is 54. Okay, so 6n is 54. Doesn't that mean that n must be 9? Because I divide by 6 and divide by 6. N must be 9. So let's go back here and let's try. 9, 10, 11, 12. All right, and let's check and see if we found the right numbers. 9, 10, 11, 12. So going back, it says 8 times the sum of the first and the third. Well, the first and the third is 9 and 11, and I add them and I get 20, and 8 times 20 would be 160. Okay, so is equal to 40 more than 10 times the fourth number. Well, 10 times the fourth number would be 10 times 12, which would be 120. So is 160 equal to 120 plus 40? It is. Our check works, and our numbers are 9, 10, 11, and 12. So that's a lot of work. Okay, I copied my problem too big, but there's the work and the answers to your last practice problem. Hopefully you're able to understand that. It got pretty tiny down there at the end, but we got it done. That's your last practice problem. So now you get to work them on your own. This is Mrs. A, and may God bless your day.